So now that I've talked about ways of using interrupt and is interrupted and interrupted to stop a thread, let's talk about ways of using these interrupted mechanisms effectively with Java threads, because it turns out that they're rather subtle. And it also turns out, mercifully, there are patterns for dealing with Java interrupted exception. So once something's been interrupted, it's going to throw an interrupted exception. And it turns out that there are patterns for dealing with this. So it's definitely worth taking a look at this article, because otherwise it's very subtle. So one way to deal with things is to simply not deal with it. So if an interrupted exception occurs, one thing to do is just say, hey, not my problem. I'm going to pass it up the stack and make it somebody else's problem. So here's a simple example. This is a simple example I call string blocking queue, which is going to have an instance of a blocking queue. And we're going to make a linked blocking queue for this thing. And you'll see that the way this works under the hood is that the call to put, the put and the take methods don't handle interrupts at all. They simply say it's the caller's problem. So they say we throw interrupted exception, and so we are under no obligation whatsoever to deal with interrupts that might occur. So what that means is it's really just kind of, pawning off the problem on somebody else. It's saying, all right, your problem, not my problem. So that's one way to do it, is not to do anything, but say I throw interrupted exception, so it makes it somebody else's problem. Another thing to do is to catch the interrupted exception and then do some cleanup before rethrowing it. And the whole purpose of this is typically to avoid putting the data structure or the object state into some inconsistent state by making sure the resources go back to where they need to be. Here's an example that's actually based on assignment 3B that you'll do at some point. And so if something goes wrong and you get an interrupted exception that happens here, we catch the interrupted exception, and then we clean everything up. And then the last thing we do is we rethrow the exception. So this is just a little pass-through that says, all right, I'm not really going to handle this exception in any detail, but I'm going to make sure the state stays where it is. This is sort of the Hippocratic oath of exception handling. Do no harm. Leave things in the same state you found them. It's kind of like the motto for people who go camping, right? You're not supposed to leave the wilderness in a worse shape than when you went there. Like, don't burn the forest down, that kind of stuff. Another thing you can do is to restore the interrupted status after catching interrupted exception. And the purpose of this is to preserve evidence that the exception may have occurred so that higher layers in the stack can handle the interrupts. So here's an example where we've got some function that's going in a loop, and it's pulling things off a queue and so on. And if this loop gets interrupted, then we may or may not do some cleanup. But the last thing we do on the way out is we say, all right, I was interrupted. So that means whoever's calling this method can also then handle the fact that an interrupt occurs. So again, it's sort of cleaning up, but then propagating the problem up the stack. That is actually the way you're supposed to handle exceptions in your, I think it's the, acquire uninterruptibly method for your simple semaphore. Your simple semaphore is supposed to note the fact that an interrupt occurred, keep trying to get the semaphore, because it's uninterruptibly, of course. And then on the way out, if an interrupt occurred, it says, oh yeah, I got the semaphore, but an interrupt occurred. And so the caller may be interested in knowing that and dealing with it in some way. And then the other way to do it, which is really often a bad mistake, a bad problem, is just to handle the interrupt and swallow it, right? So you're just like, never happened, right? So it's like if you drop and break something, you're like, let me sweep that up before anybody notices it. Nobody will find out, right? This is sometimes done when you use thread sleep or join methods, which require you to handle interrupts, but usually it's like, oh, well, who cares? There's nothing I can do about it. As a general rule of thumb, general purpose reusable library code should never swallow interrupt requests. This, in fact, is an anti-pattern. It's not what not to do, because it means that people don't actually know that interrupts occurred. So be very careful with how that is used in practice. Okay, so that's kind of a summary of patterns for using thread interrupts correctly to handle exceptional cases.